In this video, we're going to gain some intuition, some mathematical intuition behind how neural networks are trained given a data set. And we're going to walk through the blogs on MLPro.io, specifically the blog post titled Gradient Descent and Backpropagation Walkthrough. So we're going to train a neural network like this with 3 inputs and 1 output. This is just showing the process of making a prediction with that input, which we covered in the previous video. We're going to want to make a prediction with a neural network that initially doesn't have weights that are initialized to anything that's going to make a good prediction. There's many ways to initialize the weights. Oftentimes they're random weights. Oftentimes they're other weights. Sometimes set to all zeros. They could be initialized to a bunch of different things, and there's pros and cons. But for here, we're going to initialize all of them to 1. Okay, and the data that we're provided is this data set. So notice that there's 3 inputs to this particular neural network. So the data set consists of data of 3 dimensions. So it could be, for example, the height, weight, and salary of an individual. Who knows? But I see we have negative numbers in this third value, so probably not salary, unless they're in debt, in which case it makes sense. Anyways, I digress. So that is the input, these 3-dimensional points, and the output in the training data is binary. It's either 0 or 1. So let's say we're trying to predict whether their lease application is going to be approved or something like that. Very fun application. Okay, so if we are given these data points, the first thing we're going to want to do is make predictions with those data points. And I highly recommend you watch the previous video so that you can review how we make predictions with such a neural network given these inputs. But using what we learned in the previous video, we're going to output for this first data point consisting of 1, 2, 3, it's going to output 0.999 probability. And then if we apply what we did in the previous video for all these data points, we see that the first 2 get 0.99, next one gets 0.98, next one gets 50, and the last 2 get 0. And if we look at the true value of these data, we see that, okay, the true value here was 0, but it predicted 0.99. That's a ways off. For this one, the true value was 1. We predicted 0.99. That one was good. Here, true value was 0. We predicted 0.98. That's bad, etc. So the whole point of gradient descent is to make the y true closer to y predicted. In other words, update the weights of the neural network so that eventually the y true and y predicted are really close together. And to do this, we're going to use a very popular loss function for binary classification called binary cross entropy loss, which is the following equation. It is when the y true is 1, it comes to be negative log of the predicted value, and if y true is 0, then it's negative log of 1 minus the y true value. And so the goal of gradient descent is to minimize the loss. You could think of, loss usually has negative connotations to it. I know this is in an English class, but loss is not, you want to lower loss, and because lowering loss of whatever is usually a good thing. And so that's the goal here. We want to minimize the loss. And so in this case, higher loss is bad, lower loss is good, and we can see that play out here. So like in this first example, where y true is 0 and y predicted is 0.99, the loss is 2. That's relatively high compared to the next data point, where y true is 1, predicted is 0.99. That is pretty close, and the loss is basically 0 when we round. So we calculate this loss function for all of the data points, and to get our final loss value, we average all the loss the loss value for all the data points in our training data set. So if we average those losses together, we get 1.8333. Okay, so we've calculated the loss. Now it's the fun part. We're about to update the weights of the neural network based on the value of the loss function, average loss. And this is going to involve some calculus, and it's going to involve some review of how gradient descent works. And using gradient descent, we update each weight using this formula, but in particular we update weights df and ef with this formula. So starting with f, where we have the loss, we could say the new value of ef is equal to the previous value of ef minus a learning rate, which tells us how much we want to update the weights in each iteration or each epoch of learning. And we multiply that learning rate times the partial derivative of our loss with respect to the weight. So for df, we just swap out ef with df. So intuitively, this is saying, okay, update it by how much the loss is changing with respect to changes in ef. And so if we do that, well, first we need to, if we're going to calculate this value, we don't directly have this derivative, so we need to break it apart using the chain rule. And using the chain rule, we see that this partial derivative of the cross entropy loss with respect to EF is equal to the partial derivative of the cross entropy loss with respect to F times the partial derivative of F with respect to EF. So I'm going to pause here because I'm realizing that in order to fully explain this, we're probably going to need at least 2 videos. And so this is a good point to point out that for the rest of this video, there will be some calculus involved. So be sure to review calculus, in particular derivatives, partial derivatives, and the chain rule. And once you've reviewed that, continue to the next video where I will continue to explain the gradient descent process with backpropagation. So see you in the next video.